Good morning, people. My name is Josh Long. I'm the developer advocate for the Spring project here at Pivotal. I am going to be riffing on a project that a gentleman named Phil Webb and I developed before, and I also had the help of the amazing Spencer Gibb and the good Dr. Sire and Oliver Garrick in preparing this content. So I really want to say thanks to all those people, all those amazing, helpful people. Their Twitter handles are there. You should definitely give them a retweet. My Twitter handle, my email, and GitHub is there. If you have questions, concerns, thoughts, comments, hate mail, feedback, whatever, don't hesitate. I'm always happy to hear it. I'm forever at your service. That's why the email's there. If you leave this webinar with more questions than you entered, now at least you have recourse. What does it all mean? Why are we here? It's Tuesday, the second day, and not the third one. I have the answers. Just send me an email. Speaking of Tuesday, today is the day I put out a roundup called This Week in Spring. It's a aggregation of the latest and greatest stuff in the community. So please be sure to check that out. If you can subscribe to one blog every week, well, change your life so you can subscribe to more. But if you still can't, then that's the one you should get. You should follow. It's a good roundup of all the great content out there, including all sorts of great videos from the recently concluded last week Spring 1 Dallas, where you'll find lots of content on microservices, which of course we're going to talk about today. So don't hesitate to check that out. I myself am, besides being an engineer and a gnat on all the other engineers' ears, am really, really enthused by Spring Boot and by the possibilities of what we can build on top of it. And it seems like increasingly Spring Boot and Spring in general are serving as sort of this cohesive glue for Pivotal, right? If you look at all these great open source technologies, some less open source than others, but still all these are great technologies that live under Pivotal, and they work very nicely together, and I think Spring is very much that integration point. It's a way of tying together disparate services, runtimes, languages, technologies, services, infrastructure, etc., and letting you build something awesome. And increasingly, we're seeing people talk about building microservice-style architectures. So with this webinar, I wanted to we'll spend a few minutes addressing the why, but at the end of the talk, I'll give you some links to some really, really great talks that you might check out at your leisure after we've concluded here, of course, to kind of understand more about the dynamics that led up to the rise of microservices, and we'll focus mostly today on code. So, okay, a little bit of background. First things first. This whole idea of a micro-architecture versus a monolithic architecture is not a new thing by any stretch of the imagination. Hype-tastic though the idea of microservices are today, they have as their roots some very, very basic, obvious engineering principles, obvious enough that I'm reasonably sure that most of you have stumbled upon them sort of at some point in your architectural careers. Anyway, right? And that's sort of the point. These are the best kept secret, the best kept open secret. We can look back. I think this is actually a fairly illustrative point. This is an email from Ken Thompson of Unix fame from back in 1992. He was participating in the famous Andrew Tannenbaum, Linus Torvalds debate about the merits of a microkernel, a microkernel composed of independent, free, flying sort of processes or components versus a monolithic kernel like Linux. Right, and Ken Thompson, again, of Unix fame, Unix, the thing that, makes processes awesome, chimed in and wrote, I would generally agree that microkernels are probably the way of the future. However, it is, in my opinion, easier to implement a monolithic kernel. It is also easier for it to turn into a mess in a hurry as it is modified. And to that I say, right on, Ken, right on, exactly. Way to see the future, way to peer 22 years into the void and understand the debate that we would be having right now at the distributed systems level. Microservices and monolithic services are two sides of a coin. They're, it's not like one is inherently evil. It's just sort of one is easier to start with, right? Monolithic servers, just like monolithic kernels, are easier to start with, and it's for this reason that they're sort of very entrenched, right? The astute readers, the astute listeners among us will look at this email and think, well, wait a minute, just hold on a sec there, Josh. Don't get ahead of yourself. After all, if microservices are the way and microkernels are the better design, then, isn't there sort of a fly in the ointment? Didn't Linux, a monolithic kernel, didn't that prevail? Isn't that the winner? And indeed, it is. In the space of kernels, the monolithic approach makes a lot of sense. You need something super small, super compact. Inter-process communication is imperative, as by definition, it dictates the speed at which everything else on the system runs. And it's not that large. I mean, Linux, of course, is a huge project, but the kernel proper is actually very small, and it has to do very few things. That's why most things eventually get moved into user space wherever possible. That's the nature of an operating system. So in the case of this very specialized, very unique example, building everything as compactly and as co-located as possible makes a lot of sense. It's just that you eventually struggle when you try and scale out, right? This is why applications aren't supposed to, even in Unix, they're not supposed to be developed this way. If you look at the pipes and filters model, this is very sort of representative of more of a microservice approach, taking a bunch of singly focused, loosely coupled tools and composing them to build bigger systems, right? Even Unix at the user level proposes something that looks more like a microservice architecture. It's only the kernel that gets to get away with this. And the reason is because at that level, you are prioritizing efficiency of development, you're prioritizing iteration turnaround, you're prioritizing a lot of other things ahead of sheer, capacity of bandwidth and speed. How fast I can pass a byte from one component to another is far less relevant when I have 1,000 nodes. I'm going to have to scale anyway. I'm going to pay the price no matter what and do it efficiently. That's the question. And there are other things that are sort of wrong with monolithic applications. I'm sure most of us have already seen. At first, they are, as I said, easy to get started with. They are, after all, the natural approach, right? I've got some code. Might as well just add another class to it, another module, just layer on top of it until I have this giant sort of assembly or deployable unit. This becomes untenable. I don't know how many of you have had this experience, but I'm not going to lie. I've worked at more than a few organizations where I stumble upon a code base with, tens, 20, hundreds of thousands of lines of code, and no single developer has a hope in Hades of understanding where to start, let alone where the component or the module or the piece that they're hoping to work with ends. You can't reason about a system if you can't understand its boundaries, if you can't understand the impact that that little water drop in the pool will have if you make a change. So this is, it's fairly intuitive, but we don't actually see people moving that direction as much as we'd hoped, and now they finally are, right? This is microservices. You can create tools to sort of optimize for this scenario, right? Obviously, there are efficient sort of optimizations you can do to make working with monoliths less painful. You can provide a good packaging system. You can provide class level isolation. But again, eventually you get into this creep between components and you get this coupling. And by its very nature, if you have a piece of code that's more than a handful of developers, that is to say it's more than a few teams worth of developers working on the same code base, now you have synchronization issues, right? You have the question of when do I deploy? Is my piece of the code working versus theirs? Do I want to push mine to production and then come back and merge their branch and then push that to production? Does that make any sense? Can they even work concurrently on that piece of code while I work on this? And is there a chance that we can join up at the end? You have all these really sort of nasty hairnets, that again, there are ways to fix this, right? There are ways to work around it. Like, for example, Git makes it very easy to clean up a nasty merge. Git is an optimization for a bad pattern. You shouldn't have these problems in the first place. That's sort of, I guess what I'm trying to say. That's a smell. If you have too much code that collides with each other, maybe that code should be split apart, teased out. Scaling a monolith is harder by definition because everything has to be scaled. All the co-located services, infrastructure, etc., have to be scaled out at the same time, even if they don't need it, right? They say that a chain is only as strong as its weakest link, and that's the same for a co-located system, or any system really, but at least with a distributed system where the components are teased apart, you have the ability to scale out for capacity the individual components that are holding back the process. By introducing asynchronous messaging and integration, something that Spring Innovation, for example, has long since made very easy. You can decouple. You can introduce synchronous decoupling, right, and temporal decoupling. So these are hallmarks of a good distributed system. It's also easier to introduce new technology and to introduce more innovation and to maybe take more risks when components are teased apart and exposed through their network interface, through their network endpoint or their service tier. If I'm building something that needs to do something low level, perhaps I'll look at Go or C, maybe, and I can expose a microservice on top of that. If I need something that, Spring, I'm sure I'm going to have many use cases for Spring. I can deploy a Spring-based microservice here, maybe another one that delegates to Batch over there, another one that talks to Hadoop, whatever, right? And I don't need to feel any qualms about introducing middleware like a database or a message broker, because if it suits my microservice, then that's fine. I'm not imposing upon the footprint of somebody else's piece of functionality. They don't need to know how to set up Cassandra just because this one little piece of code needs it, right? That service is a service into itself. I can deploy it, manage it, scale it, evolve it, independent of other pieces. So I get faster turnaround time, get faster iteration cycles. I get the ability to go to production quicker, and this of course leads to what Ticketmaster's Rodney Barlow refers to as boardroom agility, the ability to react to the marketplace quicker, right? So it's a virtuous cycle. Faster deployment means faster evolution in business, which demands faster deployment and faster iteration, etc. Moving on. We understand the problems. There are, when we talk about microservices, there's no static scheme. It's more of a set of ideas, a set of constraints upon existing architectures. It's a style, if you will. And so I'm going to describe some key characteristics common to lots of different microservice architectures. These are not all required. You don't have to consume them all or take them all to heart just for this to work. But these are typical of a lot of different systems that I've looked at. I've had the privilege of talking to senior engineers at large companies dealing with lots and lots of scale, right? Really, really crazy scale. I think China is an amazing story there. They have Taobao, which is the online eBay, Amazon marketplace sort of thing in China. In 1 minute, they had more than 10 million concurrent users on the website, generated more than $3 billion in 24 hours. This is to say almost 300% of what eBay and Amazon and other Western retailers combined had generated in 2012. So we're talking about crazy scale, in a single day, I mean. We talk about, obviously, Ticketmaster. I think they said on the panel at last week's the Spring One Dallas that they did something like $45 million every hour on, again, a Spring Boot-based workload. The Taobao and Baidu use case, by the way, is also Spring. And, of course, Netflix, right? Netflix is, we've all heard the numbers. I'm sure you've heard the number that something like 80% of all internet traffic and the prime time hours in the States is Netflix, right? So again, crazy scale. And it turns out that a lot of these systems share common characteristics, right? They're usually, as Martin Fowler says in his article on the topic, they're usually smart services with dumb pipes, right? So these are ubiquitous network transports like REST and AMQP, as opposed to a centralized message bus or a centralized broker, right? You have just common, easy-to-consume services. This is not a Corba service either, for example. These things should be easy to deploy, easy to scale, right? Easy to deploy and easy to scale are two different aspects of the same thing. If it's easy to scale, then you get the ability at runtime to optimize for demands and to scale back down. easy to deploy is a developer concern, right? It means that you have no fear in redeploying and updating and making changes, and it means that any developer can take the code and work with it quickly and get started with it, and have no fear about diving into something for a day, making a change, and then being done, right? It should be easy to get on-ramped into a piece of code. My friend Chris Richardson talks about Fred George. I've met Fred George, and I liked his talk, but I'll be honest, I first heard about this through Chris. So he talks about this analogy of the human body, right? The analogy that the human body is a distributed system full of agents that act on their own. They're autonomous, the cells, the individual organs, etc. But it also degrades gracefully. If you were to prick the finger, you might have degraded functionality, blood, whatever that means, healing. But you don't blue screen, The human body doesn't just stop working just because the little part of you is in trouble. That's a very, very good, resilient, distributed system. The whole corpus survives despite some downtime here and there. The human body is optimized to embrace and react to a failure appropriately. And a good microservice architecture is similar to that. In fact, Netflix talks about their chaos monkeys, this idea that they release autonomous agents into their production clusters that have the function of just tearing stuff down, ripping it out of working order, just to make sure that the systems are built to handle that. Another characteristic of a microservice architecture is this idea that instead of, and again, I heard this from my friend Matt Stein, who is, of course, referring to a Neil Ford discussion, this idea that you have agents that are choreographed, not orchestrated, right? So if you think about a symphony, there's one guy controlling the whole lot of them. That's orchestration. Whereas you go to a ballet, you have a whole bunch of people acting in unison, doing what they need to do towards a goal. But there's not any single agent controlling them. They all work on their own, and if something happens, they adapt, right? They rebound and carry on. And that is, again, this is a hallmark of a good distributed microservice-centric system. There is no single point of failure. So with that in mind, let's take a look at, sort of what do we mean? What does it mean in practice to actually build a microservice? Why do we care? I mean, is microservice really just about small code? What does it mean to be small, After all, Spring Boot is super micro. I mean, look at this. This is actually and by the way, I'm the first to admit, we love using Groovy. It's a nice language. It's convenient. It's very, very concise. And you can, in tandem with things like Spring Boot or Grails, you can write some tweet-sized executable programs, which is great. I mean, that's awesome that you can do that. But I'm going to go ahead and just be the hipster here. I'm using Java in this example. This is actually almost working Java, except for the semicolon at the end of the last import. It's going to ruin everything. I won't be able to sleep tonight. This is almost working Java code. Is working Java code, save for that semicolon. And it's a working service. It'll actually stand up a web server for you, assuming you have org spring framework boot, if you have the Spring Boot starter web dependency on the class path, this will actually create a REST service that you can use. It'll actually work. You can just maintain install it in Java -jar and off to the races. So that is definitely micro. And while Spring Boot is definitely a large way there, it's a huge step in the right direction. It embraces a lot of the hallmarks of good microservices. One of my favorites is Michael Nygaard's amazing tome, Release It, in which he talks about making applications production ready. The punchline is that applications that are code complete are not necessarily production ready. There's the last mile between production readiness and code complete can be a very long one indeed if you're not ready. So he talks about being production ready by default. Spring Boot is production ready by default. It comes loaded to the gills with all sorts of great stuff to make it so that you can deploy your application, monitor it, and understand it, see what's happening, etc. With little fear. It's the ops person's best friend. So I won't show you too much about Spring Boot per se. There's a video I'll link you to at the end of the talk. But Boot is definitely a huge step in the right direction. However, when you start building larger distributed systems, you'll find, as many others before us have found, that you need more. right? There are patterns that emerge, and these are patterns that are common to many large applications. Like I say, I expect that if you were to buy a beer and corner the senior architects at Google, eBay, Twitter, Amazon, Netflix, Taobao, Baidu, Ticketmaster, whatever, they would all recount basically the same architecture. These patterns are common enough that it makes sense to, pin them down and make them as easy as possible to consume. And the Spring Cloud project, the brainchild of Spencer Gibb and the good Dr. Sire, does just that, right? It's actually a collaboration that builds upon some of the great stuff that the Netflix guys have been doing. Netflix, by the by, uses Spring Boot. They're a big Spring Boot consumer, and a lot of what they've done is we've had this sort of virtuous feedback loop where we've improved Boot for them, and then there's been innovation going back and forth, and that has resulted in this really, really lovely project called Spring Cloud. So Spring Cloud is an umbrella project. It's got connectors for consuming PaaS-based services as well, but it also has integrations for all the different pieces and for different patterns common to microservice architectures. So what we're going to look at now, having waded through all that, is code, right? Let's see here. Can you guys see this? Is that big enough? Peter? Bueller? Okay, well, we're just assuming that you can't. I'll make it a little bigger, just in case. Okay, hit OK. So this is a project that you can find on GitHub. There is, by the way, a great example that Spencer and Dr. Sire put together. It's on spring-cloud- is it Spring? No, I'm sorry, spring-platform-samples. You might check that out if you like. I find the example to be amazing, but I really wanted to do a clean room implementation of the Doge service that I introduced in the previous webinar that Phil Webb and I put together, and in the talk that we gave at Spring One. So what I'm going to introduce all these patterns, these concepts here in terms of this service that I've implemented. First things first, distributed configuration is...
Josh, your font size is a bit small, just so you know.
Even in the code, like so.
Much better. Sorry. A couple people were commenting on it. Go ahead. Sorry to interrupt you.
No problem. Thank you. I was asking. So the left is a little small, but I'll be sure and I can try making the. Do you want to do a screen size? Is that going to work?
No, the code's fine. I think that's what matters. You're good.
Okay. Okay. So let's look at the first pattern: configuration, distributed configuration management. The idea here is that you have a lot of nodes in production, and you want to be able to centralize configuration. After all, if I have 100 nodes, the last thing I want to do is to log into each node, or even SSH automatically into these nodes and update configuration. And for this, you have this idea of a configuration server. Netflix has one, but it wasn't open source, and it turned out that that's probably okay anyway, because the resulting configuration implementation that we got is actually quite nice. So what you're going to see is that these are different modules. These are all basic Spring Boot projects. You can build projects just like them by going to start.spring.io and filling out the normal pro forma sort of stuff on the form. Here's the basic form. Check the boxes you want to check, for example, web and JPA or whatever, and then hit generate, and you'll get a Maven project or a Gradle project. Choose Java 1.8. That's good for you. It's good for you. Lots of vitamins in that Java release. Good stuff. Choose that one. But otherwise, these are just basic Java projects, basic Spring Boot applications. So public static void main, Spring application that run. It's going to look at the configuration class, start it, and then create an application context for that. It's going to look at the Spring annotations. And of course, you're going to see a few familiar friends. This is the Spring Boot help me annotation that says, Mayday, Mayday, do as much for me as you can as possible. This is the Java config annotation. We're going to ignore the @enable Eureka client for now, and we're going to focus on @enable config server. What this is going to do is going to basically install all the Spring MVC machinery to run the configuration server. So all you need to do is hit go, right? I'm going to undo that, run, and whilst that's loading, let's look at two files here. In Spring Boot, by convention, Spring Boot will look for any property file named applications.property, or if you have a library called snake.yaml on the class path, application.yml. YAML is just a hierarchical way of configuration. So you can store files as server, enter, space, port, or server.port if it's a property file. Same thing, it's just a little bit more clear when you have redundant subheaders, right? So what we're saying here is server.port 8888. So the config server is going to run on port 8888. We've used this handy-dandy trick to turn off the logging to off for the Netflix Discovery packages. You can have it however you like. And then we've told the Spring config server to look at GitHub, right? We want a centralized configuration inflection point after all. So this is a GitHub repository that contains inside of it property files or YAML files. Your choice. I've used property files, and these property files are loaded when they're demanded and exposed for other nodes in the cluster to see. So we'll take a look at that. But the first thing to understand is that each node, each application, has a bootstrap.yaml. And a bootstrap.yaml is a Spring Cloud convention. It gets picked up by Spring Cloud if it's available, and it's used to configure things like the application name. Spring.application.name equals config server in this case. We'll see a lot of different places where this is used. In our case, if we had configuration in this app, and there was a file named config-server.properties, then the key value properties in that property file would be made available for property placeholder resolution and for injection by the environment object. So this is a very convenient feature of the configuration server. Any other node will implicitly look at localhost :8888 by default, but you can override that. So for example, here's the Doge service, right? A service that we'll look at in a second. And it is going to specify that its name is called Doge, D-O-G-E-S. And Doge, for the record, is that guy. Oh, so warm and cuddly. We've built a silly app that'll take that dog, which is actually a fairly ubiquitous meme, and then add Doge-isms, exclamations like such boot, so JavaScript, etc. I'm sure you've seen the images in the meme. So this is the name of the app. If there's a property called Doge.properties in GitHub, and it turns out there is, then those properties will be made available for any client that wants to consume them, right? So I can actually have this injected into my code. So we'll take a look at that. This application actually does inject some of those values. So you can see we've got very so much count, very so much -1, very so much -2, and then you can either have it equals or just a space. So it's saying very so much -1 equals pivotal IO space abstract factory bean space Java, and these are triad, a trinity of exclamations that get rendered and superimposed onto the image by the Doge service. That's done through this Doge photo manipulator, which is a library that uses Java auth and some image manipulation primitives in the SDK. We don't need to review it. Suffice it to say that we're injecting a value here, right? The property vary so much count, which is an int, and that we're using the Spring environment abstraction to get properties vary so much -1 through, n, where n is the count of exclamations that we got from this value here. So we've only got 2 values here, so the count is 2. It'll go to 1, it'll go to 2, it'll inject the values, and then voila. So we can start this up now. Here we go. And notice that when it starts up, it deletes everything in the database for us. This is just to ensure a clean slate. So this is now running on port 8082. Right? If I go to localhost 8082, I get a Spring data REST generated endpoint, complete with a menu of which service to call to do what. Basically, this service takes any arbitrary ID, and you can use this ID however you want. It means nothing to the Doge service. It's just a correlation ID, right? So I can post an image to this and give it a correlation ID, and I can then pull that image back out, Dogified, using that correlation ID later on. So what I'm going to do is I'm going to post our little Doge image here using curl. Okay. I've got 3 pictures, all equally awesome. I think it's important to have variety in a demo. So we've got 2 pictures of Doge because it's a Doge demo. And then for good luck and because all serious enterprise systems need this, we have Dave Hasselhoff. Now, I know that some of you may object to the cute, cuddly Doge picture, and we can all unanimously agree that Hasselhoff has to be here or it won't work. But Doge has to stay. It's kind of the name of the demo. So, sorry. Okay, anyway, here's the command. Okay, and then I'm going to point to desktop sample -images sample doge.jpg, right? I'm going to curl. All this is going to do is it's going to post the file, the binary data in this file to this RESTful endpoint, right? 8082/Dogifier/1. And then that'll be the first result we get back from our service. So now if we revisit the endpoint here and go to Doge Photos, so like that, you'll see that we have this one image here. I'm going to open this up in a editor that will give me some links when I want them. Thank you. Voila. Okay, so I'm going to open this up here. If I click on Photo, I get the first one, right? Very Spring IO, such boot. And that lines up with what you have here. Spring IO, boot, and then iorized. It's cyorized. Well, it's been blocked off, but that's the gist of it. I can do the same trick again. This time we'll do the Hoff because Hoff makes right. So, okay, revisit our endpoint here, refresh. Now there's a second reference. There you are, second one. Click on this one, and you get the Hoff, right? So cyorized, very Spring IO, such boot. So in this case, it got the same triad of expressions, but it's random. So in theory, the next one could be different. Now, what if I want to change those expressions? Again, very useful business service use case. I'm sure we've all dealt with having to make the Hoff look better in production. Go here. We can go to GitHub, and let's just change something. I don't know, Spring IO. Eureka, right? Okay, and then we're going to make this to be groovy, right? So that way, both will have changed. We'll be able to see that we've changed them. And all we're doing is committing onto GitHub, and we're going to curl. We're going to do curl -d empty, and we're going to hit the endpoint. That's going to create a post, and we're going to hit the endpoint on 8082 called refresh. This is going to trigger a reevaluation of the properties on the remote server. And you can see the keys that have changed, very so much 1, very so much 2. And now, even better, if I go back here, you can actually confirm. I got to just close this window. It's useless. Go away. If you go back to here, you can confirm the updated keys and values, right? So the configuration has been updated to reflect what we've just done. Again, if I go to the command line and submit yet another file for the measure, doge1.jpg, that's the other Doge. We've got 2 now, hit refresh, we should have 3, yeah. And visit this one, and there's the Pivotal IO, such groovy, abstract factory bean, wow. Okay, so this is live reconfiguration of a bean. It's pretty easy to do that actually, right? The key here is this @refresh scope. So when the configuration server sees updates to the configuration properties, and then we hit that refresh endpoint, it tells Spring to reinitialize any bean so annotated with @refresh scope. And this is a perfect chance for it to reevaluate the properties that have been updated in the property configuration. So already we've got something pretty darn useful. I mean, this is, all kidding aside, the service itself is pretty terrible, but like the ability to actually refresh configuration like that live is very powerful. You can imagine binding a data source to these kinds of configuration properties and then reevaluating it and redeploying, restarting it. Spring will actually lazily initialize this, so you won't, if you have logging or a breakpoint in here, you won't see it be instantiated until somebody does something with it. So the very first time I call the Doge service, that's when this bean gets created. And then, of course, after I refreshed it and called it again, you'll see it reevaluate again. Okay. Okay, so not bad. I'm going to go ahead and shut down the Doge service for now, because can. Okay, close that. Another emergent pattern in large distributed systems is this idea of service registration and discovery. Again, I had enough trouble with remembering the ports and the hosts and all that just in a simple little demo. Can you imagine the nonsense that you'd have to go through to make this work with any kind of scale, with any kind of deployment complexity? And again, even on a cloud, you still want to have a sense of which node is the leader, which node is alive, which one is not, which server should be considered offline, etc. Right? Even if you're doing rolling restarts, it's still good to have that resilience. And the other benefit of service registration and discovery is that routing can now be done client side. Sure, you can install some global rules at the edge of the network, but you want to tailor that for each application, and each application should have the ability to decide what happens in the case of failure, right? Where it should go next. And if you keep that routing client side, it's very easy to do. But the first key to that is to make sure that you have a global registry where services can be observed, managed, and so on. So in the Netflix stack, they use something called Eureka. Eureka is a service registry. It's dead simple to set it up with Spring Cloud. I've got another Spring Cloud project here with one dependency. It's Spring Cloud Starter Eureka Server. And inside there, I've got one public static void main class, which is simply Spring application that runs the Eureka Server application. That in turn finds the @enable Eureka Server annotation, and that triggers the creation of a Eureka registry, which gets launched and run on port 8761. The name of don't need that. The configuration for Eureka, we can turn all sorts of levers and knobs here, but there's a configuration for both the server and the client, and we've left the server configuration as is by default. It's interesting, this Spring application name is actually what's going to be used to register with Eureka. So we're going to go ahead and start this up, and then all the other nodes that are running that have the @enable Eureka client annotation on them. Remember, we saw that earlier in the account application and the Doge application, @enable Eureka client. So we're going to go ahead and start this up. All those nodes will register themselves with this service registry and make themselves available for discovery. Eureka is one of those things that you should probably, that if you agree upon one fixed address in your network topology, let it be Eureka. If you have to put this behind a load balancer on say Cloud Foundry and then assign DNS to one thing, let it be Eureka. The rest is all fluid, but Eureka needs to be in a well-known place for everybody. By default, it's going to look for it in a certain place. It's going to look for it in 8761, but of course you can override that. So I'm going to go ahead and open up Eureka here, this browser, localhost 8761. You get the snazzy Eureka console, and you can see that the config server has already registered itself retroactively. Remember, it's still running. We haven't shut it down or anything. And if I click on this, I get taken to the info endpoint, the standard Spring Boot info endpoint. Here's the env endpoint, right? And then here's just the root for config. By the way, config will also show you the properties that are in Git. So if I wanted to look at the master branch of Git for the Doge application, that is to say doge.properties, I can go to /doge/master, and it'll actually parrot what you've got in Git. So this is confirmation that we're looking at the configuration server here. I'm going to go ahead now and start up the application, the account application. The account application is a service that manages just typical username sort of stuff. And it's an ID and an account username. And in theory, we can correlate photos to this user, right, to the given user. So I'm going to go ahead and run the application. Again, basic stuff. We haven't done anything special here. It's standard Spring Cloud project. I've got Don't need that. I've got Spring Data JPA and Spring Data REST talking to an H2 SQL database. Remember, Doge talks to MongoDB. So again, we can use whatever service we want. We can use cloud-attached resources like Postgres and whatever, MongoDB, Pivotal HD, etc. And then I've got the Spring Cloud Config client, which tells this, it helps this library and this module consume configuration properties from the configuration server. And then I've got the Spring Cloud Starter Eureka, and that's the bit that actually installs the service registration bit that makes available the @enable Eureka client annotation, and that actually automatically on startup takes the Spring.application, that name, and registers it with Eureka. So here's Eureka still. I am going to refresh. We see a config server is there right now. Refresh, and now you can see accounts. The account service is there as well. Go to that endpoint. You get the info endpoint, of course. Go to / and you get a listing of all the accounts in the system. And I'm going to go here, and you see I've got just some friendly names, basic usernames, and I'm going to go ahead and I can see links that are relevant for all this. This is Spring HotOS, right? This is HAL encoded, HAL encoded metadata about these entities, about these resources, right? So if I want to know about the entity, this account, I can see that here. If I want to know salient, resources that are relevant to it but are not embedded underneath it, I can follow the links. So there's a link to get back to myself. That's this one right here. But what I'd really like to do is to see the photo for this user, if there is one, right? So I need Doge to be up and running, after all. And this is a good chance to see that service discovery working. So I'm going to say Doge application.run. It's going to start up again. And then in the meantime, we'll go back to the account application and see what's happening behind the scenes, right? In Spring HotOS, anytime I render an entity, say an account, it'll JSONify it and then add metadata about that JSON called links. And these links tell the operator, the client, information about the service, about the resource. You can augment those links yourself, right? So here I'm going to create a resource processor for resources that are describing account objects. Right? These are the JPA entities that we've got going back and forth, and we're marshalling using Spring Data REST and Spring Data JPA. I want to be able to say, whenever there's an account resource, where did I put it? Right here. Whenever there's an account resource, call this method back, call this process method. And inside that, I'm given the resource object, which has the links collection, as well as the payload, which is the account. And I'm given a chance to add a custom link. And what I do is I use this Doge integration object. And this object is, I've just injected it. It's just defined right down here. It's a 5-10 line piece of code. And that's going to use the Eureka discovery client to look up a service given its application name, Doge, right? So I'm going to say, find me the instance of this service if it's available somewhere on the cluster, and give it to me. And if it's available, then build up a link here. Don't get me wrong. There are cleaner ways to do this, but there are I wanted to make sure you guys followed me on this one. So it's a URL, and I'm just adding the Doge photo endpoint after this. You can build up that link a little bit smarter, but just at least you understand what's going on. So I'm going to say, find me all the photos for this account ID. This is the same ID that we used when we curled the photo up to the service, right? So Dogeifier /1 to get the image. It's going to be account ID /1. And so if that service is available, you'll get this link. And if it's not, well, we'll come back to that. You'll get a fallback scenario, but I'll explain that in a second. And if it's available, we'll add it to the collection of resources to be rendered. So I restarted Doge. You can see that Doge is now available in the Eureka broker service registry. And now if I refresh this, you'll see the Doge link is now available, right? So I can click on this. I go to, because I restarted Doge, it deleted the photo. So I'm going to go ahead and upload one photo quickly and then refresh the page. I get a resource representation, click on the photo, and there's my uploaded image that I just created right now, right? So that's very convenient, right? I have the ability to react based on the availability of systems. I can create a working system that has slight degradation in some capacity, right? And there's a lot of different ways to do this, but having an awareness of the topology of the cluster is a very, very helpful first step in doing it, right? Now, I mentioned that this might fail, right? And I want to have the ability to minimize even that. For example, if I were to call this service, if I were to call this method and an exception is thrown or something goes terribly awry, I don't want the whole application to stop. I just want it to fail fast and then call a fallback method, maybe do something default, or in our case, just return null and do nothing. And that's easy to do using Hystrix, right? So Hystrix is another project from Netflix that's all about managing cascades of failures in a system. And it provides lots of great patterns, one of which is called a circuit breaker. The idea is that you can call a method or a service or whatever, something that might break, something that's volatile, so many times, and if any of those calls fail, the annotated service, the annotated bit, is called a circuit breaker, and it'll open the circuit and thus stop any further calls to the broken service. It'll just call the fallback method for you by default. So it's very, very convenient. What I'm saying here is, at Hystrix command, whenever somebody calls this method, if it works, great. If it doesn't, call this method here, and then give a default response, right? So you might say, search is not available at this moment, or, doges are not available at this moment. So you have a lot of convenience here. And that, of course, with Hystrix command and all that is enabled by @enable Hystrix, which we looked at, but glanced over very quickly earlier. So I want to see some of what Hystrix is doing for me, and it turns out that it's very easy to get a dashboard up and running. I've got another module here, just a simple public static void main as well. Spring Cloud Starter Hystrix dashboard. In the configuration properties, I have the Spring application name is Hystrix. The application name is Hystrix, and some basic Eureka configuration, nothing fancy. And then I have a public static void main with a controller, and all the controller does is it forwards to the Hystrix index.html page, and then I have @enable Hystrix dashboard. So when I run this, it'll spin up on port 7980, localhost 7980, and what I have here is actually a fairly pedestrian endpoint that I can then open up a stream. So each time you see @enable Hystrix in any of those other projects, for example, in account service, you see @enable Hystrix. What that does is it broadcasts this Hystrix.stream, and actually that's what we're going to monitor right now. This is the port for the account service. So I'm going to say monitor the stream of Hystrix errors and non-errors and all that stuff from this account service. I'm going to go ahead and hit monitor, and that's going to open up, and it's going to have information about the build Doge link circuit that we've created. Now, watch what happens when I go back here, and I want to get the Doge link for the photo. Oops, wrong one. Doge photos. There we are. So if I click on this one, well, not seeing enough activity to make a difference. I have to really refresh pretty quickly, but suffice it to say, you should see the activity there. That's kind of interesting. What's happening? Circuit's closed. Doge photos. Anyway, if you trigger enough, it'll eventually present the graph, and if something goes wrong, it'll actually say that the circuit is open in red letters. So this gives you the ability to sort of monitor how well systems across the cluster are doing. Now, moving forward, one last really cool piece of this project is the dynamic router, Zuul, which I'm told is named for for something in mythology, and it also has it's also in Ghostbusters. It's a gatekeeper, the gate API, and of course this matches a pattern. It's called the API gateway. They talk about that in the Flix blog article. I list down there, but it's also on Chris Richardson's amazing microservices.io. And the idea behind Zuul is that you can do a lot of routing if you can deploy routing rules at the edge of your cluster in your code, right? So it's not an operation person's problem. It's your concern. It's something that's managed with your application. And you can even externalize the rules for that inside of Git, right? So you can change them at measure if you like. I haven't in this case, but the point is it's very simple. So what I'm going to do is, in this case, is I'm going to use Zuul to aggregate both the Doge service and the account service under a single host and port. And that makes it easier for me to consume those services from an HTML5 JavaScript client, for example, which might otherwise struggle with cross-domain, cross-origin request issues, you know. So I've got a little client here. Again, I just want to demonstrate that this works, but again, you could very easily put in JavaScript and HTML5 and WebSockets and all that and see how this stuff works. I've got a client. It's a Java client. It has Spring Cloud Starter Zuul, so that's going to set up the proxy for you. And then there's some really convenient mapping properties. So I can say that I want to expose all of the Doge photos service, which is called Doge, which has a host and a port that's going to discover by talking to Eureka. So it's going to use Doge, call Eureka, and figure out where the host and the port for that service is, and then it's going to mount that service under /API/Doge photos. Same thing for accounts. It's going to go to Eureka, find the accounts registered service, find the host and the port and the context and all that for that service, and then mount the same service under /accounts under /API. So it's going to be API/accounts, API/Doge photos. This will live on port 9900. And then other than that, this is just called a client, so that's going to show up in Eureka as well. To get it running, I just have a public static void main just as before, and I've got @enable Zuul proxy. Here we go. Start that up. And localhost 9900. Go to API accounts. There's the accounts information, same as before. In fact, you can see it still thinks it's even on that service, on that port, right? And then same thing for Doge photos. You can see it thinks it's still there, right? Because it is. It's just proxying the data back and forth for you. But the client doesn't have to know that, right? So you can compose and aggregate and control and do a lot of other declarative things using this proxy, including, for example, security. That's another application. Lots of great opportunities here. And so far we've seen how the Spring Cloud project can help you build complex distributed systems to make them more resilient, to help insulate them from cascading failures. We've seen how you can centralize configuration and thus greatly simplify deployment concerns. You can even refresh and reload configuration in production. So I think the Spring Cloud project does a lot of great stuff for you. I've just touched on a small sample of the things that you can do. One thing I would have loved to show is the encrypted and decrypted configuration that the configuration server supports out of the box. But we must move on for want of time. A few moments here, a few notes. It's important to note that, just in this simple little demo with just 4 pieces of infrastructure, right? I had let's see, Zuul, I had Hystrix, I had Eureka, I had the config server, so that's at least 4 pieces of infrastructure. Sure, I could have taken all those annotations and just put them all in one class and had all 4 of them co-located in one jar, or I could deploy them. But, the point is when building a distributed system, especially one like what Netflix builds or something, it gets distributed very, very quickly. It really, really stacks up. And so it can become crucial that you have a deployment strategy that's repeatable, that's easy, and that doesn't have a lot of friction. Spring Boot supports classic.war. Of course, you can run Spring Boot inside of your typical environments, but today's applications, typical of, like, for example, 12-factor applications, are processes. And Spring Boot by default gives you a jar, a fat jar that you can just do Java -jar with. The configuration mechanism, property files, YAML files, environment variables, command line arguments, etc. It's unified. So you can use any of these approaches. You can say, for example, export Spring _application_name, and then set that as an environment variable for your application in lieu of setting it in the property file. Or you could do -d, spring.application.name equals whatever. And to Spring Boot, it's all the same thing. And since it's easy to understand and reason about how to configure and stand up a Spring Boot application, the only thing you really need to worry about is deployment. Who's going to ferry the bits from my machine to production, right? Who's going to stand them up, make sure that they're sitting behind the load balancer, make sure that they have enough memory and RAM and so on, and basically the feed and carrying of the application in production. Well, it turns out that a platform as a service is ideal for that. And Cloud Foundry, by far the most popular sort of open source platform as a service, is natural for this. You can actually describe complex deployments, with multi-nodes using a manifest, right? So the manifest is super simple to describe. You just literally on the order of a few lines per app, per node, per module, whatever. So for example, this working system that I have here could be one little Cloud Foundry manifest, do CF push, and the whole system, Hystrix and Eureka and all the stuff, is up and running in Cloud Foundry, and it's just all aware of each other, right? So definitely consider a cloud. And of course, the Spring Cloud offers support for working inside of Cloud Foundry and Heroku. There's connectors for those different environments. The connectors are particularly nice because they let you work in terms of middleware, of infrastructure. I want a data source. I want a RabbitMQ, message queue, etc. But I don't care about whether I had to look it up inside of JNDI or I had to look it up inside of an environment variable inside of the cloud or whatever. That's the nature of dependency injection, right? And Spring Cloud PaaS connectors make that happen inside of the cloud. It makes it easier to work with. I've used REST for all these examples, but it's worth noting that there's nothing that's specific about REST and microservices. You could just as well have used RabbitMQ, AMQP, the protocol. You could have just used some other kind of endpoint, and it's not hard to imagine Spring integration being used for complex integration flows that kick off either from HTTP or maybe a message that comes in on RabbitMQ or JMS or whatever, or even something as inane as an email. Again, Spring integration doesn't care. It can consume services from anywhere. It can consume and handle requests from all sorts of places. And Spring XD, similarly, can consume inbound requests from lots of different sources, and then it can be used to really, to massage data in a big data pipeline very nicely. So again, there's no reason you couldn't stand up Spring integration or Spring XD as a service endpoint, register them with Eureka, and enjoy their same benefits. In this talk, I've conveniently glazed over configuration of security. The good Dr. Sire has an amazing talk from the just recently concluded Spring One Dallas that talks about using Spring Security OAuth to provide federated authentication and authorization in a distributed system. This is a natural. This is a great fit, and it gets even nicer if you plug in the Spring Session project. The Spring Session project is a way to plug in alternative backends for your HTTP session implementation. The same session, for example, that stores your access tokens or your JWT tokens for your security context. There's no reason your Spring Session implementation couldn't talk to, for example, JDBC or Redis or Cassandra or whatever, right? And thus be visible cluster-wide. And you get, session replication is not the greatest thing, especially in your traditional application server. But who does session replication very well, or rather node replication? Cassandra, or Redis or whatever. These are all things that know how to do this very, very efficiently. So plugging them in with Spring Session is very, very nice, and you can now build a very secure federated service infrastructure. Now, with all that said, I would like to encourage you to check out these numerous videos and posts and so on. Adrian Cockcroft, formerly of Netflix, now at Battery Ventures, he's a VC guy, has a DevOps-centric look at microservices, which I think informs certainly that side of the movement. And it's good to understand that when looking at microservices in terms of how it affects code. As I mentioned, this Spring Doge example is just a riff on something that my colleague and Spring Boot co-lead Phil Webb and I created and presented. We presented it at the last at Spring One, which just recently concluded. That should be up online soon, I hope. We tend to tickle these things out one by one after the show on InfoQ. But in the meantime, check out this Bootiful applications with Spring Boot. It's a talk I gave for the Virtual Jug that introduces the same thing, and it introduces Spring Boot. So if you have questions about Boot proper and all these low-level bits, then do check that out. My friend Chris Richardson has a great website called microservices.io, and formerly a lot of great talks called on the subject. It's amazing. Again, the benefit of microservices is that we don't have to prove it. It's already been proven. It's the architecture that we've all sort of independently arrived at to deal with kind of scale. So you don't even have to. You may not even know people are talking about it because they don't know the word at the time. One such example is Chris Richardson's amazing decomposing applications for scalability talks. He doesn't really use the word microservice, but what he's describing is a microservice architecture, and that's exactly the beauty of the style. It's innately correct. We just know that's how it needs to work, and you can see it evident in Netflix and all these other large organizations. Netflix, speaking of, has a great tech blog. Do check that out. I mentioned Fred George earlier, who talks about the body, the corpus, as being a distributed system that should degrade gracefully. That was from a talk on programmer anarchy, which again I found by way of Chris Richardson. My friend and colleague Matt Stein has a nice talk called Cloud Foundry and Microservices, a mutualistic symbiotic relationship, which I think nails it's perfect for a quick 30-minute look at the business motivations, some technology motivations, but also, the why behind microservices and how that plays nicely with the cloud, right? So we've looked at the code, we've looked at how this informs your architecture in this talk. That looks at how it informs your operations story. It's a very, very good watch, and it's only 30 minutes, so do check it out. And of course, the venerable Martin Fowler, he's got his website, and there's a great, very, very highly reviewed and respected write-up article on microservices linked here. Do check that out. And with that, I'll take questions. I am, as always, Josh Long. Here's my Twitter handle and email if you have questions, and we don't get to them in here. Please don't hesitate to reach out. I'm always at your service. And, of course, there's GitHub. So GitHub, Spring.io guides, lots of good stuff there. Check out Spring Cloud samples, Spring Platform samples, Spring Doge microservice, and, of course, Spring Boot. Okay. That'll do. Peter, how we doing, buddy?
We're doing great. I'm just responding to one gentleman. Give me a half second here. In the meantime, let's see. Okay. Shoot, I think he left. Oh, well. I just want to say thanks, and come back and join us next week if you're into BPM as a topic, business process management, workflow, BPM. Joachim Barres and Josh Joachim Barres from Activity and Josh are going to be talking about doing process-driven Spring applications with Activity, and that's next week on September 23rd, which is a Tuesday. So please feel free to come back and join us for that. I'm just going to pop the link for that into the chat window right now in case you're interested. This is being recorded. We're going to be posting the replay to spring.io/video, and then we always wrap the video in a blog post at spring.io blog. So don't drop off your email and ask us to send it to you. Basically, just subscribe to the Atom feed at Spring.io, at Spring.io blog, or the YouTube channel at Spring.io video, and then you will get a notice that the webinar is available. Now, we did have one question that I wanted to run by you, Josh.
Yes, sir.
Rick Herrick asks, what's the coexistence between Groovy Grails and Spring Boot? And I told them about how Grails 3.0 is being rewritten to run on Boot, and I was just wondering if there's anything more you wanted to say on that topic. If not, no worries.
You pretty much nailed it. It's just Grails has always been about exploiting the dynamicism of Groovy to really, really provide more convention or overconfiguration, more than even what you can do in Java. And so, like, for example, we saw that manifest in the keynote at Spring 1. Do you remember that? Like, we have we're fond of doing a REST service using Spring Boot, but the Grails guys, not to get done, did a complete microservice that was using Grails based on Spring Boot that you could fit in a tweet. So they're just awesome. They're doing amazing stuff. It's a collaboration. A lot of the stuff that they contribute, like a lot of the stuff that they developed, has now been teased out of Grails and made available so that you can consume it from Spring Boot. For example, GSP, the Groovy server pages, etc., and Gorm. So it's a good mutualistic symbiosis, as Matt would say. Very, very good situation for both.
Cool. Thanks, Josh. A lot of people asking about where to get the PowerPoint. We will link to that from the video, and most likely we link to it to Josh's speaker deck profile. So, Lynn, if you're looking specifically for the PowerPoint presentation, you'll be able to get it off of speaker deck. And
all my
a PDF of it off of speaker deck. One other question that I wanted to review was, where was it? Vineet Bhatia asks, can Spring Cloud-based microservices be hosted on-premise?
Of course.
I responded saying that Pivotal Cloud Foundry offers, is designed exactly for this solution, and exactly for this use case on top of VMware's vSphere, and just wanted to know if you exactly OpenStack, AWS, yep. So, was there anything you wanted to add to that, maybe?
Well, I mean, it bears mentioning that I'm not using any. I'm paying for it in complexity, obviously, but I'm not using any cloud for the whole demo. Everything we've seen has just been me running Java processes. So I'm running it locally, right? There's nothing. It's not intrinsically. It doesn't require cloud. It benefits from it immensely, obviously, because look at all the pain I've had to go through to figure out which process is running where and all that. But it definitely can. Absolutely. And I recommend Cloud Foundry because I recommend it because everybody else does. There's a reason they all recommend it. It's a really, really good tool. Good approach.
Yep. I think similarly, Tobias asks if there's a recommended practice for continuous deployment of Spring Boot applications. We find that the war-based deployments work well within a CI ecosystem, but a running jar is much more difficult with local command execution. Spencer responded already to say that the same infrastructure is required, that is required to run an app server like Tomcat WebSphere is the same that's, for a Spring Boot, like a Java process. And
right. Yeah. It should be easier, actually, not the other way around.
Yeah. Yeah.
So, because with Tomcat and all that, the CI container needs to know how to set that up, whereas with a regular jar, and again, this is not an either or. You can have WARs with Spring Boot. You can even do a Java EE here with the Spring Boot application inside of it. Not that I'd recommend it, but you can. But with just a regular jar, it's just a jar. Every container knows how to run that. Don't have to set up anything.
Yep. Okay. I think the only remaining question, and this might be a little bit more for Spencer, so if you want to punt on this one, that's fine. But Corey Showers asks, isn't Docker a microservice solution with standalone Tomcat?
Well, so is Docker a microservice solution for standalone Tomcat?
With standalone Tomcat, sorry. Isn't Docker a microservice solution with standalone Tomcat?
It's a little bit high level, right? That's about, it's a container for your running process. You can deploy it, you can use it. There's upcoming work to support that in Cloud Foundry. Or you can just describe the same basic stuff inside of a Cloud Foundry manifest. However you do it, you want to have, you want whatever it is you're managing to look the same. And Java, Spring Boot, Java applications look and are operationalized the same way. So it's very easy to to scale that effort out. You don't have to guess. Nothing is a snowflake, you know. And with Cloud Foundry, that pays off big time because now you can riff, you can iterate very, very quickly because you know that everything is going to work a certain way. People don't have to guess about Snowflake deployments.
Last question that I think is definitely a good one, and I've heard this one answered before. Does Spring Boot support JAX-RS from Anuj? And I think Josh, well, I'm pretty sure we don't do anything special to support JAX-RS. There's nothing to prevent you from using JAX-RS on top of Boot. We're just not bootifying it.
Right, and actually, the good Dr. Sire did have a. Let me see. He did have a JAX-RS 1 and 2.0 integration. It's simple, right? It's just a prototype. It's not actually supported, but Sire. It's on his GitHub.
Spencer just linked to the GitHub Spring Boot jersey.
Yep, there it is. Sire Spring Boot jersey.
Okay. So, we're at 20 minutes after, where there's still a large number of people on the line. So this is great. I think we're going to have to call it pretty soon, though. Well,
I invite you guys to continue the discussion online. Obviously, I'm at StarbucksMan, BUXMAN on Twitter, and Spring Central, and Spencer B. Gibb, one word, no space, David_Sire, Philip _Webb, 2 L's, 2 B's, Oliver Gierke, Gierke, no space. These are all people that can help you with this kind of discussion.
Yeah, it's not difficult to find us online, guys and girls. And if we, if all else fails, we do monitor Stack Overflow. If you go to the homepage of Spring.io and look at the questions tab, you'll see a list of the GitHub tags, list of the Stack Overflow tags that we monitor. And there's Josh showing you all the various and sundry Twitter handles that we were just referring to a moment ago. So, Josh, awesome talk. Thank you so much. And Spencer Gibb, thank you very much for helping out with the ton of questions. It's clear that this is a hot topic. We'll be back with more on this front. So stay tuned. And like I said, please join us next Tuesday for process-driven Spring applications with activity on September 23rd. And if you weren't able to make Spring 1, check out the blog for a Day 1 and 2 wrap-up, and you'll be seeing videos start to come out on spring.io/video in the coming weeks and months. Thanks so much for your time, your attendance. Josh, you want to say anything to wrap it up?
Just thank you, Spencer and Dr. Sire. My slides would be terrible if there was nothing to talk about. So the Spring Cloud stuff is really great. Thank you, guys.
Awesome. We hope you give it a try and give us some feedback because we're just starting on this road and we'd really love to hear from you. So thanks for that. And if you guys do try it out and you have questions, ping us. And if you write a blog about it and you want to see it featured, and send us a note and we'll put it in This Week in Spring. Thank you. Sorry. Yeah, that's a very good way to get noticed by the Spring team right now is to write a blog on microservices and Cloud Foundry in Spring. Hint.
Subtle
awesome.
hint.
Thanks, everybody. Very subtle.
Thank you.
Have a great day, everyone. Bye.
Thanks, Peter.